Welcome back. We're going to start the next session. We're the first one to start. OK, so the next session is Razvan Ionescu. He's going to talk about broadcast internet fuzzing framework for Android. Go for it.
Hi, everyone. First, thank you for joining this session. My name is Razvan. And so to say, I have multiple identities. First of all, I'm a security QA engineer working for Intel. I have a 3 years experience so far. On the right side, you may see some other kind of identity of myself. I was a kind of survivor. Survivor, you know, maybe the show from US television. Well, there was also an edition in Romania at Reznov, and I was one of the participants of that edition. Some other identity, actually, it's a kind of hobby I enjoy a lot, and I play when I have time. It's called geocaching. Do you know this kind of thing? Are there any geocachers in the room? Cool. Here you may see one of my latest discoveries until so far. It's a newspaper post from a city very close to the Pacific Ocean, nearby Santa Clara. And yeah, you may do a lot of things with this kind of hobby. You may visit places through the eyes of some local people who wants to share with you some beautiful views and you know, portraits and so on, landscapes, sorry. And also you can do some other cool things. For example, you may ask your future wife to propose her using geocaching. You may just go, for example, with her, and instead of finding a geocache, she may find a ring or so. Well, let's get back to business. I'm here today to present you an open source project. It's called Broadcast Internet Fuzzing Framework for Android. And today, I have discovered how can you enclose this project into a joke. There was a speaker called Cristiano on the opening session, and he told a lot of jokes regarding a credit card walks into a bar. Well, my joke goes like this. Maybe you know. A QA tester walks into a bar, and he asks for a beer. He asks for 0 beers, for -1 beers, for 99.99 beers. He asks a lizard, and he tries not to pay. And the bartender says, well, have you thought that we may raise you an exception? That was my joke. So for today, I will propose you some questions, like why, what, how, who, and where. And of course, I will provide you the answers to those questions. And also, in the end, I would like you also to hear some questions from you and some, I know, ideas in order to improve this project. Well, why have we built this project? Well, how many of you are Android users? Pretty much all of you. OK. And how many of you do you care about security when it comes to mobile devices? OK. So Android operating system is a pretty important target due to the fast spreading rate among the end users. So this operating system is very, very spread, and it's very important to be secure from this point of view. Well, one of the methods in order to test if an application, as a developer, in order to test if your application you have just developed is secure, is by fuzzing intents. What is this? Well, as you probably know, in Android, there are so-called inter-process communication mechanisms. And one of them is through intents. One activity is sending an intent to another activity in order to open it, or it passes some data, and so on. Well, those intents, as you will see later, have sort of parameters. And through this project, we have tried to manipulate these parameters. BeFiles, this project, is written in Python. It's open source. It was licensed under MIT license at the beginning of this year. And more than that, we have used Key. Key is an open source Python framework where you write Python code and it generates through a bulldozer an Android APK. So founding this kind of environment, this kind of framework, we have just made, I say, a big step from a local application running on a Linux device to a single standalone APK. Well, from architecture point of view, because any project must have kind of an architecture, basically you can connect multiple devices in the same time. It may be also different kind of Android devices to a Linux host machine. And BeFiles has multiple modules. You may see that it has a data collector, which it extracts data based on the dump sys of each package. And having this data collected, it generates afterwards intents. As output, we may have, of course, error logs, seed files, delta reports, and this APK I have told you about. Well, what is the seed file? For example, by running multiple intents, multiple calls, so to say, an application may crash. But it may not be because of that particular call, but it may be because of a whole trace. And inside those seed files, we save the whole trace, the whole list of calls, which produces that crash. The delta reports, well, we simply compare two behaviors of the same application or two behaviors of two different builds, Android builds, in order to see if having this image is better, in order, so to compare two images in order to see which one is better from security perspective. If you want to see like a workflow, well, we have the Android device connected to BeFiles. BeFiles is running and it collects data. It stores all those data in files. And afterwards, after it builds the intent calls, fast intent calls, it sends them back to the system. And this system may generate, of course, error logs if it's the case. Or you may have also the standalone application. This is how it looks like. You may see there are like 9 features. First, you may select any device under test. You may select particular devices or all the devices which are connected to the Linux machine. You may generate either broadcast intents or simple intents, generate delta reports, and so on. One other important feature I will focus on later is this SQL injection for specific APK. You may see that through those intents, you may run also SQL injections. A short example, how does a broadcast intent look like? Well, it has this parameter, which is the device ID. That one is a fake one, of course. And as parameter, it just receives the package name and the broadcast receiver. Well, before doing this project, of course, we have done some research. And there were some guys who actually succeed to find some crashes, some native crashes, inside famous apps like Facebook and PayPal, running those kind of broadcast intents. They couldn't handle properly this call, and they crashed. Well, a fuzzed intent, we generate them based on some templates. Because first we have tried to generate all the intents. You see that there are 6 different parameters. And those 6 parameters may have like between, I don't know, 20 to 60 types of values. And this resulted in billions and billions of combinations. And it's not doable to run those kind of amount of intents through a device. Well, we came up with a solution. And we generated 64 different kind of templates. And we have coded this name with 0 and 1. So you may see here template 0, 0, 0, and so on. All the parameters are not fuzz. So 0 means no fuzz. And 1 will mean fuzz. Well, if you specify that a parameter you don't want to be fuzzed, you may also specify a particular list of values. So, OK, you don't want to be fuzzed, but what do you want to be there? And the calls will look like this. So the only fuzz parameter is -a from here, action. And because I have specified the list with items like act1, it generates an intent with act1 for this parameter. If not, it simply goes into a specific file and read the values from there. Another example where everything is fuzzed. So you see 1 is fuzzed. Well, everything is fuzzy there. So every parameter receives fuzzed data with different random length and values. Well, by running those intents, one particular application may crash or not crash. Well, for example, you have here a log from logcat, an example where an application has crashed. This is due to a transaction to large exception. The parameter received as action, you see here on the first line, was a very large and fuzzy parameter. And it produces actually a denial of service attack. By running those very large intents and too many, we may succeed to make the device not responsive. If you try to open any app, it will automatically close. As I said at the beginning, we have used KV, and we try to make this application standalone as an Android application. But with this, there are a lot of challenges we are still facing, actually. You see here an example. How does the user interface look until now? Simply, you can select a package to test for broadcast intents. And if you select one application, well, you see the result on the right side. Every intent call is saved on the logcat with f parameter at the beginning with a fatal tag. And this is because we want to better filter these logcats. It's easier. Another example, we have succeeded to run SQL injections using intents. We have used for that also a framework. It's called Drozr. They published an application. It's a password manager application, which is vulnerable to SQL injection. And we have tested also our project against that application in order to see if we are doing properly or not. And for example, you just create your credentials for Yahoo and Google and so on. And by using our app, also our project, you may retrieve in plain text the credentials. As my joke stated, there are a lot of exceptions you may find. Unfortunately, not all of them are exploitable. So maybe they are not so interesting from an attacker point of view, but still. And also, as I said, we may succeed at the denial of service attack. My project wouldn't be possible without help from my colleagues. And I want to mention here Andrea, Bogdan, and Christina. Christina is a student, and she was the person who learned KV in order to export our application to an Android application. Also, you may find our project on GitHub. You may scan the QR code, or you may enter the link. I may also tell you some other challenges we have to cope with. For example, if you want to send a lot of data through ADB, it has some limitations. And because we wanted to simulate a buffer overflow attack, we have created those intent calls, which are very large, and saved it in separate files, and then pushed them to the device and run it from there. This is how we have bypassed the ADB limitations. And that was pretty much my presentation. I would like to hear from you some suggestions and any questions, please. Yeah, please.
One quick question, maybe I wasn't paying attention, but can you also test attacks via content providers with BeFiles?
Which one?
So can you test some attacks using content providers?
Yes. Actually, this module for SQL injection, it requires access to content providers. And it's easier for now to have this, but only using the Linux version of BeFiles, not the APK. We couldn't retrieve the content providers, the fully path of the tables.
The URI. Oh, okay.
Yes, yes, yes.
Okay.
I don't know if there is any solution we would like to hear. We couldn't retrieve this.
Okay.
Yeah.
Thanks.
Any other question? OK, in that case, we're going to continue in 5 minutes with the next session, which will be preparing your apps for Internet of Things. So I'll see you back in 5 minutes. Thank you.
Thank you.